My name is Stefan Wiedemann. I'm Senior Software Engineer at Seamware and at FIWARE, and I'm also the main developer of the FIWARE Data Space Connector. And today I will talk about FIWARE Data Space Connector and its integration with the IDSA Data Space Protocol. Let's have a short look how I want to structure today. Because first I would to give you an introduction into the IDSA Data Space Protocol and what it actually is. Most notably with its reports, catalog protocol, the contract negotiation protocol, and the transfer process protocol. And since they are often used, let's say, or talked about together, the IDSA protocol and the Eclipse Data Space Connector, I will also have a very short introduction to what the Eclipse Data Space Connector is and how this belongs to the Data Space protocol. And the second part will focus mostly on the integration with the FIWARE Data Space Connector. First, we will start with the integration of the catalog and the transfer process protocol. We will also have a live demo of this then. And at the third part, we will also take a look at the integration with the contract negotiation protocol. This is separated because catalog and transfer process protocol are already fully supported by the FIWARE Data Space Connector, while the contract negotiation protocol currently is under implementation. So we will have, let's say, a different type of explanation about this. But hopefully after that you're well informed on how the integration with the dataspace protocol works in the FIWARE Dataspace Connector. But let's jump right into it. What is the IDSA Data Space Protocol? So data exchange between different dataspace implementations in general requires a common understanding between the participants in terms of data model and also the protocols that are used for the data exchange. In order to do that, we're usually separating into different, let's say, topics of the data space interactions. And I took a look into the DSC blueprint, which mostly separates it into three parts. First one is the data model that defines and uses the shared semantics in the data space, the data exchange, which actually defines the capabilities for exchanging the data itself. And there's always also provenance and traceability, which is focusing on tracking and tracing of the sharing process. Today, we will mostly concentrate on the second part, the data exchange capabilities for actual exchange of data, because that's what the IDSA Data Space Protocol mostly focuses on. So it essentially provides the mechanism for the actual transmission of data. And the DC blueprint itself also refers to the IDSA Data Space Protocol in your data exchange recommendations. So if you want to build a data space following the European recommendations, you most likely also have to take a look into the data space protocol from IDSA in order to get or in order to be safe to have the level of data exchange that you want between different connectors in different data spaces. Now let's dig a little deeper into the protocol. So in general, it's a set of specifications that is designed to facilitate the interoperable data sharing. What does it need? So we need schemas and protocols for publishing data, but not only publishing them, but also negotiating agreements between the participants on how to access the data and who is allowed to access the data and under what conditions, and also the data access itself and how the process of accessing the data should be structured. The IDSA Data Space Protocol was initially created and maintained by the International Data Space Association. It's now an Eclipse specification project because they are targeting to become an ISO standard. And the Eclipse Foundation has kind of an ISO fast track program, so they somehow contributed it to it. That's why it's also sometimes named the Eclipse Data Space Protocol. But no matter what name you hear, so IDSA Data Space Protocol or Eclipse Data Space Protocol, it's the same protocol. And the protocol itself consists of three elements. The catalog protocol, which mostly focuses on the part of publishing data. The contract negotiation protocol, which focuses on negotiating the agreements about data and data access. and the transfer process protocol, which mostly focuses on structuring and controlling the actual process of transferring the data and exchanging the data itself. So now let's take a look into the concrete parts of the protocol. I would start with the catalog protocol. The catalog protocol in general is a relatively easy interface for offering data sets and data services as part of a data catalog. The catalog itself uses DCAT3 to describe the data objects. I'm not sure how familiar you're with DCAT3 or DCAT in general, but it's essentially a specification language for catalogs and data objects and data services and data sets that they just reuse for creating the catalog. It specifies the information flow between the participants when they actually exchange catalog information. So how should the catalog be made accessible and how somebody can read and understand it. And one thing that's important for us, it also defines a so-called HTTP REST binding. We can have a short look at it. Which defines the endpoints and also the data that can be accessed through those endpoints as part of the specification. And in the Dataspace connector, you will see we more or less just implement the HTTP REST binding to become compliant with the IDSA Data Space Protocol. Now let's have a look how such a catalog looks like. This actually is, let's say, very small and simple entry. So this is a very small and simple entry of a catalog. So I left out a couple of things that are not necessarily belong to the, are not necessarily that relevant for the example, but you can make a catalog much more expressive. So what we have here is, as usually, we have a context on how to interpret the contents of our document, a type, which for the catalog is DCAT catalog, and an ID. What you already see here is that we are using an NGS ILD compatible ID here. This is mostly for the integration inside our FIWARE Data Space Connector, where we can also see the for our Data Space Connector, where we because we want to relate the entries of this IDSA catalog together with our entries in our backend. But that's something I will get into more detail when I'm talking about the implementation. We have entries like when was this catalog issued, the catalog has a title, and usually it also has entries like themes, like keywords, like description, and so on. But I left it out because it wouldn't have fit the screen here. You also can define policies, mostly in ODRL, that might describe how this catalog should be accessible, how it can be used, how it cannot be used. So whatever you can express as an ODRL policy, essentially. And in this catalog, then we have a list of services or data sets. In our case, services is the more important one, which then describes the actual catalog entries. So we have, in this case, an entry of type DCAT service. It again relates to an entity inside our internal data inside our Dataspace connector. And we now here have also some keywords, some descriptions, the URL where it's accessible. Also, again, something about when it was issued, the title, and the description. And this is essentially the information that somebody or a consumer can use to find information about the available data services and data sets from our data provider. And with those information, he can then go into the actually contract negotiation. So in order to actually access data, the consumer and the provider need to find an agreement about the conditions, on what conditions they should be allowed to access the data. In the real world, this is normally just a purchasing process where you have a contract in the end. And with the contract negotiation protocol, this is essentially brought to a digital world. The contract protocol in IDSA describes the process of a provider and a consumer of one or more data sets coming to this agreement. So the consumer essentially selects the data service that he wants to have and then goes into negotiation with the provider. This negotiation more or less is a state machine where the negotiation protocol and the consumer provider together iterate through a series of states and exchange some messages in between. Those messages are mostly belong to the entries of the contract, or to the contract that should be that they want to come to. So the consumer in its request state essentially proposes a contract, or how to use the offering. The provider then can take a look at it, change it, offer something else. The consumer can then change it again. And so they can exchange those negotiation messages until they come to an agreement and go to the accepted state and go to some, let's say, more verificational states until they actually have a contract that both of them can use for their data access and both of them can rely on. Every of those negotiations is based on a catalog entry. So the initial message and all subsequent messages will link to one of the entries of the catalog service, of the catalog protocol. And yeah, we again have a REST binding defined in the contract negotiation protocol, which should be supported by the provider and the consumer. So it essentially has two sides. One is the path bindings on the provider side, which essentially means these are the endpoints that a consumer can contact or can connect to in order to change the state of a negotiation, make proposals, or actually also find out about the current state of its negotiation. And there is also a binding for the consumer callback path. So under certain circumstances, it might make sense that the provider not only changes the current ongoing negotiation at its own endpoint, but also sends back some information to the consumer that actually this change has happened, so that the consumer then automatically can react again. But also that's something we will have a deeper look into when we come to how we are intending to implement this as part of the FIWARE Data Space Connector. After the contract negotiation and the contract negotiation protocol, we're coming to the transfer process protocol. So as you think from, let's say, three-step process, we already have the catalog where we have found out all about the data service that is available. Then we went through the contract negotiations, and now we have an agreement in place on how consumer and provider are exchanging the data between each other. And now we're in the transfer phase, so of transferring the data, or what you also could say of accessing the data or the data service and using it. And there the transfer process protocol comes in place, because it describes the process of a provider and the consumer of those data sets, how they want to interact in the concrete data exchange. We again will iterate through a series of states that control the flow of this data flow or this data exchange by consumer and provider, again through a set of defined messages that allows us to start the process, stop the process, suspend it for time, or in the end also complete and terminate it. This again supports not only the pool transfer, which is something we have very often, so essentially a consumer just going to the provider and requesting the data, getting it back, or just interacting with the service on the side of the provider, but it also supports push transfers. So essentially the consumer says, I want to start a data exchange, and with that the provider starts to send the data to a defined endpoint at the consumer. Data can, in this case, or in terms of the protocol, also be infinite or finite or non-finite. The difference here is that finite data, for example, would be, let's say, a JSON document that you want to request and get back in as the document itself. Non-finite data is more something like stream-like data. So you're subscribing to a constant flow of temperatures, for example. Yeah. The transfer process protocol also again defines the REST binding. We're here at the same page again of the International Data Spaces site. And it defines also, again, a provider side and the consumer side. So at the provider side, we can interact from the consumer. The consumer can connect to the provider and then start transfers, request them, and also control the flow of this transfer itself. And there's also a callback path to the consumer, where the provider could provide information about the current state of the transfer process and also change the state of this process. For example, if he has to, for whatever reason, to suspend the push or if he wants to stop that the consumer is currently pulling the data for maybe because he's under too heavy load or for whatever reasons. So this is essentially the state machine of the transfer process protocol. You can see this is already a little easier than the one we've seen for the contract negotiation, because we mostly have only one state that allows us to actually transfer data, which is the state started. Every transaction itself or every transfer process itself starts with the consumer requesting for the data transfer, and then the provider has to enable it by setting it to start it. When we're in state started, the actual data exchange can happen, and then both sides, so provider and consumer, can suspend or complete the process or even terminate it. Suspend is the only state where you can get back into a started state. So suspend is essentially we're hitting the pause button and want to continue our data exchange at a later point in time. When we're in state completed or terminated, the transfer process itself is finished, and we should start a new transfer process if we want to exchange data again. Every transfer process has to be related to an agreement. So we always have to provide the information for our current transfer process, what the, let's say, contractual base of this data exchange is. This agreement needs to be, will just be linked in our transfer request message, but it needs to be there. There is no transfer process if there is no agreement between consumer and provider available. So now that we have taken a look into the IDSA protocol itself, we're coming to the Eclipse Data Space Connector. As you know, I'm mostly focused on the FIWARE Data Space Connector, but the obvious question, the obvious target of our IDSA protocol and other exchange protocols in data spaces is that different connectors are interoperable with each other. And if people talk about the IDSA protocol, they most of the time also talk about the Eclipse Data Space Connector, because this is could be seen in part as a reference implementation of it. So to make this a little more clear, I want to give a short overview what the Eclipse Data Space Connector is. Essentially, it's an open source framework by the Eclipse Foundation for building data sharing services. That's very similar to the FIWARE Data Space Connector, which is an open source framework by the FIWARE Foundation for building data sharing services. Okay. The Data Space Connector provides components for control planes, data planes, catalogs, and decentralized identity. Also very much, as you know, from the FIWARE Data Space Connector. One difference of the IDSC is that it's very much focused on machine-to-machine data exchange. The Eclipse Data Space Connector does not provide so much functionality, or you could say not at all, but that's probably debatable, for data exchange in a human-to-machine nature, which is something that we at the FIWARE Data Space Connector did put quite some focus on. The Eclipse Data Space Connector itself implements the IDSA Data Space Protocol, but also another protocol that is often seen together with the IDSA Data Space Protocol, but is actually a completely separated protocol, which is the Eclipse Decentralized Claims Protocol. So we essentially have the Data Space Protocol, which defines the structure of the data exchange itself. And there's the Decentralized Claims Protocol, which focuses on the authentication and authorization inside the Eclipse Data Space Connector. The Decentralized Claims Protocol is an authentication protocol based on verifiable credentials for machine-to-machine authentication. That's important to know. The Decentralized Claims Protocol doesn't even try to do any human-to-machine interaction. So if you want to use the Eclipse Data Space Connector for human-to-machine, you need to use a different IAM framework. The Decentralized Claims Protocol is maintained by the Eclipse Foundation, but one drawback is that it is incompatible with the OpenID for verifiable credentials protocols. We are using the OpenID for verifiable credentials protocols. So if we want to connect the EDC with the FIWARE Data Space Connector, we need to work around the IAM. There are ways around, but in general, we are currently only compatible in terms of the data space protocol, but there are differences in the IAM framework. EDCP and IDSA are, as I mentioned, often seen as ones, but they are really independent specifications, and the Eclipse Data Space Connector just implements the two of them at the moment. We currently do not intend to implement the decentralized claims protocol for various reasons, mostly because we see the OID for VC protocols as, let's say, more advanced and also more established and more flexible. The European regulation currently also, especially the UD wallet reference architecture, also references the OpenID for verifiable credentials protocols, which I see as a problem with the decentralized claims protocol because it's not compatible with the UD wallets in the future. Okay, so much to the Eclipse Data Space Connector. Now we will go back to the FIWARE Data Space Connector and focusing on how we integrate our IDSA protocol or the IDSA protocol within our FIWARE Data Space Connector. In general, the FIWARE Data Space Connector as a default covers the functionality of the IDSA protocol by using the TMForum APIs. So the TMForum APIs is a set of APIs specified by the TMForum. That's an organization essentially coming from the telecommunication sector that specifies APIs for offering services, specifying services, doing contract negotiations on them, selling them, and also controlling the use of it for multiple years already. As far as I latest newsletter that I've seen is that the specifications were used now more than 1 million times or so. So it's a really established protocol and or set of APIs, and we're using it as part of the FIWARE Data Space Connector to provide the catalog functionality, the contract negotiation functionality, and also to a certain degree the transfer process functionality. But as I mentioned, we also want to be interoperable with other database connectors, and the IDSA Data Space Protocol seems to be the most important for connections inside data spaces at the moment. We are also implementing this as a connection with the TMForum API. So let's say the source of truth inside the Data Space Connector is still mostly the TMForum API, but we're providing an additional access to the TMForum API through the IDSA Data Space Protocol. In order to do so, we are offering Data Space Protocol APIs through a component called Rainbow. Rainbow is a component developed by UPM, so the University in Madrid. The component itself is available on Docker freely. The code is not yet open source, but they are intending to make it open source as soon as they cleaned up some things in the repository and provide, let's say, sufficient documentation for the code. But this should happen, I think, essentially within the next weeks, hopefully. But yeah, the code is open source, and some of us already will be open source. Some of us have already access to it, and we're integrating it as our solution for the IDSA protocol into the Data Space Connector. Now let's have a look how the request flow actually happens for integration of the catalog protocol. As you remember, the result of this integration of the catalog protocol needs to essentially have an API that provides a decut view on the entries that we are offering as part of our data provider. If we take a look at the data provider side here, we have a data service, obviously, we have our TMForum API, and we have a component currently called contract management, which essentially handles the connection between the TMForum API and other components inside the Data Space Connector. Before integrating the IDSA protocol, that was mostly the authorization and authentication components in order to enable access to services once they were purchased. But now it's also used for integrating with the Rainbow component to actually put the information from the TMForum API also into the IDSA Data Space Protocol. I left out the authentication components here, so every interaction will usually start with exchanging verifiable credentials as part of the authentication process, but that would have just complicated the flows today. If you want more information on the IAM and the authentication authorization part, I can recommend you the presentations and videos from the Dataspace onboarding series also on the FIWARE webinars, which focused on the IAM, where we did provide much detail about that. But for today, we will have every request going through the authorization framework from the consumer to the provider. But we will also have, let's say, users of the provider that can access the internal APIs of the provider. How authorization authentication for those is provided is completely up to the provider. This could be through an internal API. This could be through the normal authentication authorization mechanisms. This could be even through a third-party service that goes through some that runs inside the environment. That's why we just abstract this part away with a user of the provider. So let's say this is an administrator, and the whole process will start by the administrator of the provider creating a catalog, the service, and also the offerings through the TMForum API. We are not just using catalog and service, which is the terms that we also have in IDSA, but we also need the offerings of the TMForum API, which is from let's say abstraction level much closer to what the service is in the DCAT catalog. The DCAT catalog separates between the catalog and its services, and you can buy access to those services. So if you think of that about them from that perspective, they're essentially the data services that are offered through the catalog. In TMForum API, this is a little bit more explicit. So you have the catalog, yes, but you can also define a number of services, and then you can build offerings around those services. Because the offering usually is a little more than just the description of the service. It also means we can define where this, under what circumstances this service should be made available. You could add price information. So what do you expect to get in money for using the service? And all this combined is the offering itself. Therefore, the TMForum API builds this explicit object of offering, and we will use the offering as the, let's say, equivalent to the service in a DCAT in the DCAT catalog. When this catalog service and offering is created, the TMForum API will send an event to the contract management. This most of the time will be the creation event, but we're also supporting update and delete events. So if the provider at a certain point decides to change the service or delete the offering, this will also be translated and updated inside the IDSA catalog API. The contract management then is responsible for translating the structure from the TMForum API into the structure of our DCAT API, and will create the relevant entries, relevant DCAT entries in Rainbow. Rainbow provides therefore also let's say an internal API for updating the data and for creating objects, because the catalog API in IDSA itself just defines the readability, but not how those entries end up in the catalog. Okay, once this is done, we essentially have an object available for our inside our catalog that a consumer can take a look at. In order to integrate the transfer process protocol, we now have to find a way to create an agreement. And as I already mentioned, at the current state, we only support the catalog and the transfer process protocol. So we need to essentially use the FIWARE Data Space Connector way to get to an agreement and to buy access to the service. This happens by a consumer creating a product order through the TMForum API. As you've seen in my example already, the catalog provided and also its entries provide the IDs to the actual entries inside the Dataspace, Dataspace Connectors model, which is the ID of an entity inside the TMForum API model. So the IDs used for our DCAT entry is the same ID that the corresponding service has in the TMForum model. When the consumer now creates a product order, the product order references the product offering that he wants to order. This product order belongs to the service inside the catalog API. So our consumer can select the offering he's interested in the catalog API, and then he has to make, in step 4, the request for ordering a product through the TMForum API. This product order contains the connection to the product offering, so that TMForum knows what product should be ordered, and also Rainbow knows which service this belongs to. TMForum API will then send the product order event to the contract management. And the contract management itself will then translate again the product order into the objects that belong to the IDSA catalog. Most important thing here is that it will create the agreement at Rainbow, because the agreement will be the base for our transfer process. And one thing that we also have not fully implemented yet, but partly, is creating all policies that additionally belong to the product offering and to the product order at the policy administration point. So it could be that the product offering contains certain conditions under which the data service should be made available. So let's say our consumer only bought access to the data service from, let's say, on weekdays between 10 and 12. Then we somehow need to enforce this policy. And this policy can be connected to the product order and offering itself, and will, through the contract management, be registered at our policy administration point, and therefore automatically be enforced in the future. Now that we have the agreement in place between consumer and provider, we can start the actual transfer process. This is usually initiated by the consumer itself, because the consumer wants to access the data service, which is here. In step 7, the client application or the consumer, it could also be a user, but we're talking mostly M2M here, so it will be some kind of application, will send a transfer request message through the policy enforcement point again to Rainbow. So we don't want to have this API open for everyone, because we obviously only want to allow the client to do this request if he's allowed to. So if it's a participant inside our data space and if we trust his requests. And yeah, the client will send this transfer request through the PEP to Rainbow to the transfer API. And then Rainbow has to check that the connected agreement exists, and that this agreement also belongs to the participants that are requesting here. So that the consumer is actually the one referenced in the agreement, and also that the provider is the one referenced in the agreement. So it should not be anyone be able to use the agreement, but only those that the agreement belongs to. If that is successful, Rainbow currently sends back a transfer start message to the consumer side. In general, we will make this part optional in the future, because all the information from the transfer start messages are already provided as a response to the request transfer. In order to make the deployment easier for a consumer, we might make those callbacks to the consumer side optional in the future, because that would allow the consumer to participate in an IDSA transaction without having the full set of Rainbow to run themselves. But right now, due to some implementation constraints, we still have those callback messages. In step 9, the consumer now then can request the actual data. Through this transfer start message, he received a process ID from the provider. So this message contains an ID that belongs to our current transfer process. And this transfer process ID should be used by the consumer as a header in the request. So we put in a so-called transfer process ID header, and this request will then be sent by the consumer to the provider through the PEP. And the PEP now will not only check the authorization of the consumer, but also the process ID in the header. For that, it will go to Rainbow and check that this PID is actually in state started. If it's in state started, the request is forwarded to the data service. If it's in a different state, let's say in suspended for whatever reason, the request would be rejected. Obviously, the PEP will also check the policies, but since that's more IAM, I left out this step here in the description, and the request is forwarded to the data service itself. Data is returned to consumer. That's more or less the full integration of the transfer process protocol. And that's what we will now see in a demo on how this actually happens in practice. For those that have seen presentations by me before, I usually use a local installation of a data space. So I set up a Kubernetes cluster with 2 participants and a trust anchor, so that we can essentially play the full set of the full flow of communication between consumer and provider. And all of this is also available as part of the GitHub repository of the Dataspace connector. So you can, let's say, replay everything that I did here after the presentation to maybe get an even better understanding of it. I already started the cluster, so it's already deployed because I wanted to save the 5 minutes or so that it takes to start the setup, so that we have more time for demo and talking. Sorry, I hope my voice will take a bit. Hold up. First, in order to actually provide some data in the FIWARE Data Space Connector, default deployment, we usually use a context broker as the data service. So I will now put some data into my context broker so that we actually can retrieve something in the future. This will be some, we call it an uptime report for some server, but that depends fully on the scenario, what data you actually want to provide. But now the interesting part is first the integration with the catalog protocol. In order to provide the catalog itself, we need to create essentially 4 objects as part of our TMForum API. The first one is a category. In the TMForum model, we essentially connect a product offering with an entry inside the catalog through the category. So the catalog belongs to a category, the products belong to a category, and then those products are offered as part of this specific catalog. Therefore, we start with creating a category. It only has a description and the name. It could also be much more rich, the information inside those entries. That's something very specific to the TMForum API, and that's something you should probably read about the TMForum API instead of just going through those examples. Those examples use those objects in, let's say, very minimized version. With the category ID now in place, I always store the response, the relevant parts of the response in environment variables so that we can just use them. We now can create a catalog, and then we can create a product specification. Our product specification, to be compliant with the IDSA format, essentially has 2 mandatory fields. It needs to contain an endpoint URL that gives us the essentially the address of our data service and a description of the endpoint. It should provide some information about the endpoint itself and how you could use it. Those 2 are important and required by the IDSA specification, and we also will directly translate them into the DCAT. Now that we have the product specification itself, we also need to build the product offering, because the offering itself is then the thing that will be part of our catalog as a service. We'll now create this product offering. The offering references the created category and the product specification. We usually could also add some information about pricing and so on, but that's not important for the example here now. We will just create the offering. Now that we have the catalog and the offering created in the TMForum API, we obviously want to access them through our DCAT, through our catalog API. This is done with a plain GET request. I have here the address of our Rainbow instance at the provider, and I go through the default, through the standard address of the IDSA protocol for catalog. And then we can see, as a result, we get a catalog. This catalog has the ID that we created for our TMForum catalog. It has an identifier, some information about issuance, title. You see a lot of null entries here and empty entries, because that's stuff that we could fill, but that I just didn't fill inside the example. But this could give a consumer much more information about the actual catalog. Same is true for the data service, where you could also provide much more information to your users, and also already some policies under what circumstances this service should be available and should be. Let's say you could, for example, define by those policies in what catalogs they should be viewed or should be shown and whatnot. Yeah, but that depends, again, mostly on your use case. The data service itself also has an ID that belongs to the TMForum API. And the one thing that you can see here is that this is the ID of the product offering. So it's not the specification or any kind of service inside the TMForum API. It's the actual offering, because as mentioned, this is the thing that we're actually referencing here. Now with our DCAT catalog in place, we obviously have now to go through to build an agreement. In order to have the authentication authorization working, because as I mentioned, every request happens through our policy enforcement point and through the authentication authorization framework, we have to set up a number of policies first. The first one, to give access to the Rainbow catalog. All those policies are ODRL policies. You can have a look later in them. I will not go into the details here because that would just too much for this presentation. But I will just create them. So we also allow the registration of organizations at the TMForum. We want to allow creation of product orders. We want to allow certain users to actually read our uptime reports. We want to allow them requesting a data transfer, and also to read the consumer to read its agreements so that it can use the information from the agreements in the downstream. And then in order to actually access the endpoints, sorry, that was a little quick. To access the endpoints, we need some verifiable credentials that we can use for authentication. We're using two different types of users here. One is a plain user that will mostly do the interaction with the TMForum API, and one that is called the operator credential, which will be used to actually access the data on the data service later. This is interesting mostly because you can differentiate then also on the consumer side who is allowed to actually use the service and who is allowed to make the purchases. On how you can do this in a fine-grained manner, that's also part of the IAM presentation. So I can recommend you to take a look at that. For today, you just need to trust me that we need two credentials to actually show the different access here. We also need to prepare some key material so that we can actually exchange the credentials here. But again, that's something we have more detail in a different presentation. Now, the interesting thing is that we want to get access to the data service itself. We're doing this through the FIWARE Data Space Connector. First, by registering the consumer itself as a customer at the data provider's TMForum API. This is very similar to how marketplaces often work. So you have to register yourself as a customer, let's say with your address and your payment information and so on, and then you can use this account, in this case kind of an internal ID, in the future for all orders that you make. So you only have to do this step once, and then you can reuse this information in all future exchanges. So we register ourselves as a consumer, we call ourselves a fancy marketplace, and we put in our decentralized identifier here so that the marketplace can relate later to our authentication information. Now with this ID in place, we can create a product order. So let's say we decided when we went through the catalog, for decade catalog for our service, we actually only have one, so it's quite easy to find one. We use the ID of this product offering that we had in the catalog. If you can remember, we have the catalog here. We can use this ID and add it here in our product order item as the offering that we want to actually get. And we add ourselves as the related party. That's something that usually will be done by a marketplace application, so that it's actually we that ordered the product itself. We get back an ID for the product order again. And now this product order is created in an initial state. And what now usually has to happen sorry, is that somebody it could be a human, but it could also be a machine at the provider side, has to do some steps in order to actually complete the product, be it by setting up the service, be it by sending out the bill and completing the payment process, or be it just by verifying and setting everything to okay. In order to complete our order, now this person has to go to our product order and just set it to the state completed. this is the trigger for our contract management to actually create the agreement. So only when the product order is set to state completed, we have an agreement in place, and the consumer can now use this agreement as let's say as the base for a transfer process, because we now know the service is up and running, everything is paid, and now we can actually also use the product. Now that we have the agreement in place, we can go and access the service through the transfer process protocol. In order to do so, we first need to know the ID of our agreement. This is something we can get from the information inside our product order. So our product order will contain the agreement ID that we have in our TMForum API. In order to use it for transfer process protocol, we also need the agreement ID that is available, that is used in the IDSA protocol. That's something we can get from this agreement. In general, it's also just a UUID, but that's the UUID that we're now using for our transfer process. Because now we are down in the actual transfer process protocol, where we have to start the process with a transfer request message. This one is the transfer request message that we now want to send to our to the provider in order to start the process. The transfer request message contains a consumer process ID, which essentially is just a random UUID that the consumer itself should use to track the process itself. So a consumer can have multiple transfer processes ongoing, and in order to differentiate them internally, he will use the consumer process IDs for the transfer, for identifying the transfer. What he also has to do is to provide the ID to the agreement. He has to say what he actually wants to do. So what we want to do here is doing a pull process through the HTTP protocol. Sounds very fancy, but it's just I want HTTP REST access to my data service. And we also have to provide the callback address of the consumer's rainbow so that the provider can actually send its messages back to the consumer. With all of that, we will get back from the provider essentially a message that contains our consumer process ID, but also the provider process ID. So similar to the consumer, the provider will also give the whole transfer process an internal ID so that it can track the process and that it can separate between several ongoing processes. This provider process ID is very interesting for us because that's also again the one because that's the one that will be used as the transfer process ID header when we are requesting then the actual data. So now that we have our transfer in state requested, we have to set it to state started, obviously, because we actually want to exchange data. We're doing this with a transfer start message to the IDSA transfer process protocol service, and we're relating to our consumer process ID and provider process ID to uniquely identify our ongoing process. Let's do so. Now we get back information about our transfer process. We see this is the provider ID, the consumer ID, and we're now in state started. Once we're in state started, we should be able to actually access data. So let's do this. We're doing a request through the PEP, in this case to a simple NGS ILD entity. So that's the entity that I created at the start. And we have not only to provide our authorization token, but also the transfer process ID here. If we do so, we should hopefully get back the report that I created in the beginning. Yeah, we could make it a little more. Okay. No, let's stay that way. Sorry. But yeah, you've seen we got back the report, and we see that that it essentially worked. What we now can do is set our transfer. So we got the data. We now want to set the transfer to completed. Therefore, we're sending a transfer completion message that again references the consumer process ID and provider process ID. We're going to the endpoint of the transfer process service, which is called the completion endpoint, and set our process to completion. We get back again a transfer process with the provider ID and the consumer ID. It's the same process that we've seen before here. This one, let's say 9DB and 03D. It's the same process here. And it's now in state completed. If we now do the same request that we had before with the process ID, we hopefully don't get the data because it's now stopped. Okay, now it's forbidden because obviously our process is not in state started anymore. That's essentially the whole integration of the catalog service and transfer process service. So we can go back to our presentation, because we now obviously also have to cover the process of the contract negotiation. As you've seen, we did not much of a negotiation yet in the TMForum API. We just ordered the product and lived happily with it. I think that's something that's, let's say, the default use case. So most of the time, a consumer will just go to the catalog, select the offer, and accept the, let's say, the conditions it was made available under. But in terms of having a contract negotiation, we need a mechanism that allows us to exchange the proposed, let's say, the proposed changes on the offering and on the conditions under of the offering. In order to integrate this with the TMForum API, we are using the so-called quote API. The quote API is a form of an API of the TMForum that provides a standardized mechanism for customers to place a quote and negotiate it with the provider. A quote itself comprises a number of so-called quote items, and those quote items bring the description of the requested actions on the given product offering. So you can define a number of actions that you want to do on the offering by adding something, modifying certain conditions, maybe removing something for the product offering. That's something that you can all define inside the quote and your quote items and provide this, let's call it proposal, to your provider. Based on the provider's response, based on this quote, the provider then can decide if he's fine with it or not. And he could either accept it, or he could also say, okay, I'm not accepting all of your proposals, but this would be my counter offering. Send it back to the consumer and the consumer to the customer, and the customer can again decide if he agrees or if he wants to issue a new quote by essentially providing a new proposal. After this negotiation process, we will have a quote that both of them agreed on, and this one will then be passed as an input to our product order that will be passed as an input to the product order that our customer will then create as the result of the successful negotiation. So we will still have a product order in the end, but the product order itself does not directly reference the product offering, but it will reference the quote that both of them agreed on, because the quote essentially defines the final product offerings that both of them agreed on. The quote itself also has a defined state machine that you can see here, which is important to understand, because the contract negotiation protocol has its own state machine. But first, let's take a closer look into how such a quote could look like and how it could be used to actually change the contents of a product offering. The quote itself has a similar structure like all TMForum API object. It has a description. It usually has a related party, so some organization or user that is connected to it in a certain role. It has a version and a state. And then we're coming to the important part of the quote item. So one quote could have a number of quote items, so you're not, let's say, restricted to just one change. You could have multiple of them. And in this example, we want to, let's say, propose a change in the pricing model. Therefore, we create a quote item that references our product offering. A product offering, as already mentioned, most of the time also will have a price set. And if our user now wants to change this price, he could issue create an item with the action modify. He could provide a note with some information. So he says, okay, we would now rather have a weekly payment and a discount, and he provides the price alteration. So his alternative is that he wants to have a price type recurring, charge period should be weekly, and the price itself should be €2 per week, essentially. This is now the offering that he will submit to the provider in order to get information about this. In IDSA, the offerings are then encoded as ODRL, which requires quite some processing power by the provider to actually understand what actually should be changed. But we're currently working on translating those quotes into corresponding ODRL offerings. Yeah, we have to see if all the power that we have in TMForum API can be translated to IDSA. But we will at least have a subset of them available to be compliant with the IDSA protocol. Because we're now coming to the actual negotiation process. The diagram on the right side tries to match together the state machine of the quote and the negotiation process in TMForum with the negotiation process of the contract negotiation process protocol. To start a negotiation process, our consumer first has to select the product offering he wants. So a provider has at some point created product offering in its catalog, and the consumer decided he's interested in this offering, but he wants to change it. So the consumer creates a quote with certain quote items, and this quote references the product offering. He now issues this quote to the provider, essentially by creating it at the TMForum API offered by the provider. Our state machine in terms of IDSA is now in state requested, while our quote is in so-called state in progress. In progress means now our provider has to act and has to do some decisions on this quote item. We see here on the left, essentially at every time consumer and provider could terminate the whole process and stop the negotiation. But that's, let's say, the trivial part. We now in state requested, and in this state, the provider has essentially two options. He can either change the state of the quote to approved, which means he offers the consumer those conditions. So we're transitioning to the state offered, but he also can change the quote or can change the quote to approved, but incorporate a couple of new quote items or reject and approve existing ones. So if he rejects the quote itself directly, we're terminated. But if he wants to just change certain things, he will approve the quote, essentially offer it, but with some changes. On this offering that our consumer then actually got, the consumer can decide if he wants to take it or not. So the consumer now will go through the quote itself, through the offered quote again, and check, okay, do I accept the new conditions? Then I can set the quote to accepted, and we're moving to the state accepted itself. Or he's not okay with the proposed changes. Then he will reject the quote, and he will just create a new one for the provider to decide on. And we will go through this process between offered and requested, as long as they decide to either terminate or if the consumer accepts one of the offerings from the provider. If we're in state accepted, the provider now will only most of the time will just check again that the quote is actually the quote that the consumer accepted is essentially the one that he also offered. Then he will change to agreed, or he will cancel it and go to terminated. When we state agreed, we now have our quote that both of them are fine with. And then the consumer has to create the product order. This product order is created here and will reference the quote that both of them agreed on. So we will have a product order that not have a reference to the product offering as we've seen before in the example, but now to the quote. The quote that is referenced on needs obviously to be in state accepted. And with this quote created, we're going to the state verified. If the consumer is not okay, he still can cancel the quote and everything's the whole negotiation can start again if they want. If we're in state verified, now the provider has to act. He obviously will respond with okay to the consumer, but he also has to, and that's something that we need to update a little in this diagram because that will change. This is something that actually changed yesterday during the implementation. The verified state, the product order is in state acknowledged, and it now has to be completed to get into state finalized. That's the thing that you've seen before. So only if we are in state completed, we will create the agreement. So even if we have the negotiation process with the quote is not the equivalent of the agreement inside our model. The quote is just part of the product order, and the product order in state completed is the real, let's say, object that is the equivalent to the agreement in the IDSA protocol, in the IDSA model. Okay, and if we're in finalized, we're essentially done with it, and we have the base for our transfer process. Now, since I obviously cannot show you on, let's say, a live demo, I can already show you how the request flow will work in the contract negotiation that we're currently implementing, because I think it makes more sense to actually see the contents of those requests to understand how we are actually negotiating the contents and get to the agreement in the let's say in the final state. In order to start, we again have to create a catalog and a service and a category, obviously. But what we now also have to add, if we want to negotiate the price of an offering, our product offering now should have a price. A price could define for our offering by using a so-called product offering price object, and this could have a type. So we're defining here a recurring price that will be charged monthly, and the price for a month will be 10 euro in this case. Just as an example here. We will then create a product specification again, and we will combine this product specification with the price to our product offering. So our product offering will now not only contain information about the service and so on, but it will also contain information about the price. And when our consumer now decides about the product that he wants to have, he could check the price and he can decide that he's not fine with the price. So in order to now start the negotiation, he has to create a quote. This quote will contain again some let's say normal information like a description, version, and so on, but it will also contain the quote item. Our item will reference the product offering that we just created, and it will also contain the action that we want to do, which is a modify and some information. As you can see, that's essentially the same example that I had in my slides. So this should make, let's say, may look familiar. The quote item price will, in addition to the alteration from the example, now also have the reference to the original product offering price, so that essentially the provider knows exactly what the parameter is that they want to negotiate about. And he again now requests for a change in the charge period to weekly, and he wants to have a price of 2 euro here. Now, when this quote is requested, our provider has a number of options. We could cancel, obviously, the quote. In this case, we're terminated and everything has to start again. If our consumer is happy, he can just approve it and then we're in state offered. So he just has to set the state of our quote to approved. Or I think the most interesting state or action is that he actually wants to reject the original quote item and offer its new one. So we will have a quote, and this quote will then have two quote items, as you can see here. This one is the original quote that our consumer offered. So you can see here it will have the same ID, and it was the one with the weekly period and €2. But he sets it to state rejected. We could add a new note so that our consumer knows why he wants to, why he doesn't want to accept it. But yeah, let's say the usage of node depends a lot on the context. So if this is an exchange between two machines, you probably don't have to provide some nodes. And then he can provide his counter item, just a new item with a new ID, again referencing the product offering, and also modify. And this one will directly be created in state approved, because we're creating the quote now in state approved, because that's the offer that our provider will actually make to the consumer. In the first state, the consumer just asks to get an offer under that conditions. But what our provider now returns is not just the quote itself or the request, but an actual offer that is approved and that somebody can take. That's why the items are already in state approved. Yeah, we can provide a new node here, and then the exact same way that the original quote was structured, he could provide a price alteration, let's say charge period weekly, with a different price. So he would be okay with changing the period, but he would not be okay with changing the value itself. Okay, we're now in state offered, and now our consumer can decide again on what to do. He could set the quote to state accepted if he's fine with it, and then we're also in the IDSA state of accepted, not longer in offered, because he is fine with the quote he got offered and the conditions that the provider will give him. Or he can reject the quote because he's not fine with it, and then create a new one. So he will reject the first one. It's in state rejected now. All of the quote items are now irrelevant, but he will now create a new one. Important is here that they usually should increase the version number here, so that the provider knows, okay, that's not our first negotiation about this topic, but he will create a new quote, again in state in progress, that contains a quote item now with something different. So he now wants to have still monthly, but still he now would be okay with monthly payments, but with a different value. Okay. With that, obviously, if we send that, the provider now can go back and can decide, does he want to approve? Does he also want to change that? Whatever. This could essentially go back and forth infinitely, but most likely at some point they will decide to either terminate or accept an offer. Or what the consumer also can do is just cancel the quote and go to state terminated. And yeah, if he wants to in the future go again into negotiation, he also has to create a new quote. Now let's assume our quote is in state accepted. This is essentially that that we are also in IDSA state of accepted. And if our provider takes this quote and just takes the update itself, we will answer with an HTTP OK, and we're moving automatically to state agreed. In state agreed, we now know that the provider approved the quote and the consumer also accepted it. And now the consumer can decide, okay, I now have this offer available that I'm finally okay with. And he has essentially a state of, in order to get to verification, he now has to create the product order. Our product order will now contain a product order item which references the quote itself. So the product order that is created references not our product offering anymore, but the quote that we agreed on. With creating this product order, our IDSA state machine transitions to state verified. He still has the chance to terminate the whole process, which would mean he takes the quote and sets the quote to state rejected, and therefore is then in state terminated. When we instate IDSA verified, it's up to the provider again. The provider now has to, let's say, check the product order internally. So obviously there could still be stuff that he doesn't want, that he's not okay with. Sorry. So yeah, there still could be stuff that he's not okay with. Then he would have to reject the order and go to state terminated, or he accepts it, then he will go to state completed. I added in here the agreement. This will most likely be happen automatically, so this will not be will be removed from the examples in the futures. But he sets it to completed, and with setting it to completed, the contract management will automatically create the agreement in Rainbow. It will create an agreement in TMForum API so that we have the equivalent here. Our consumer will add it to our authentication framework, and also the required policies will create it in the authorization framework. When all of this happened, we have an agreement, we're in state finalized, and our consumer can access the data through the transfer process protocol. Yeah, what I described here is, as mentioned, currently under implementation, and if nothing goes wrong, we can probably release the first version of it end of this week. So I'm mostly in testing right now. And then we have the full coverage of the Data Space Protocol available. Okay, this most likely was a different kind of demo than most expected. But yeah, I hope it gives an idea of the integration. This is the wrong heading, but sorry for that. Just if you're interested in the material, I always upload every presentation that I made under this GitHub repository. There are also the other presentations available that I talked about. So, for example, where we talk about the IAM mechanisms that you should understand if you want to understand all the details that I presented here today. And there's also the link to the FIWARE Data Space Connector repository. With that, we're essentially at the end of the presentation, and we will have a couple of minutes left for questions.